All right, these are the homework problems for parametric equations. So most of these problems are going to be with the first derivative, the second derivative, and then a couple problems will deal with arc length at the end. So I don't know if I'll do all of the problems, we'll see. But for part A, it says that show that C has two tangent lines at the point 3, 0 and find their equations. So we need to figure out what our t values are because it gave us the rectangular equation 3, 0, meaning that we are going to plug in 3 into x or 0 into y. It doesn't really matter because you'll get essentially the same thing. So if I plug in 3 for x and we get t squared, that means that t is going to be plus or minus root 3. Okay, so that means that we have some t for root 3 and then some t for negative root 3 and their tangent lines. Now in order to do that, we probably need to figure out what dy dx is. So what we're going to do here is figure out what dy dt and dx dt. So dy dt is 3t squared minus 3. dx dt is 2t, which gives us dy dx being 3t squared minus 3 all over 2t. Now, for the sake of this problem, I am going to simplify this because I know in part C, whenever it talks about concavity, I'm going to have to take the second derivative, and I would rather not use quotient rule here. This would be 3 over 2t minus 3 over 2, and then t is at the bottom here. But I am going to plug in root 3 so that I get my slope here. So that's going to be 3 root 3 minus 3, 2 root 3. So that's 3 times 3 is 9, minus 3 is 6, over 2 is 3. So I'm going to have 3 over root 3 there. And then for negative root 3, I'm going to do the same thing. But it's going to be the negative version of it. All right. And then to get the tangent line equations, that is just going to be y minus 0 is equal to 3 over root 3, x minus 3. And then this tangent line equation would be y minus 0 is equal to negative 3 over root 3, x minus 3. There you go. All right, for part B, it's asking us find the points where the tangent line is horizontal or vertical. So remember that a vertical tangent line means that dx dt is equal to 0. Granted that dy dt cannot be 0. So we are looking at that. So horizontal tangent line, that's going to be 2t is equal to 0, t is equal to 0. I'm not going to find the points just yet because I also need to verify that dy dt is not 0. So this would be 3t squared minus 3 is equal to 0. 3t squared is equal to 3. T squared is equal to 1. T is equal to negative 1, positive 1. And then I could probably plug in and see what my points are. So I'm going to have a vertical tangent line at 0, 0, whenever I plug in 0 for t here. So 0 squared, 0 to the third, minus 3 times 0, that's just 0, 0. And then if I were to plug in 1, I'm going to get 1, and then 1 minus 3 is negative 2. So that's going to be a horizontal tangent line at 1, negative 2. If I plug in negative 1, I'm going to get, let's see, negative 1 squared, so that's going to be 1. And then if I plug in negative 1 to the third, minus 3 times negative 1, that's negative 1 plus 3, which is 2. So I get 1, negative 2, and then 1, 2 as my horizontal tangent lines. For part C, I am determining where the curve is concave up or concave down, so I'm going to take the second derivative. Remember that the second derivative is going to be d dt of dy dx over dxct. Now we already know what dxct is because dxct is just 2t. And then to figure out the derivative of the derivative, remember how we simplified this a little bit. So then I'm going to take the derivative of this. And that is just going to be 3 over 2 plus 3 over 2t squared. All right. So remember that for concavity, I'm looking at when my second derivative is 0 or undefined. So in this case, that's just going to be 0. If I look at this and I make a sign chart and I plug in, let's say, -1, this right here is going to be 3/2. This is 3/2, so this is positive. -1 here would be -2. So positive and a negative would be a negative. And then if I plug in something to the right, let's say 1, this is still going to be positive. This is going to be positive. So this is going to be positive. So then the curve is concave down from -infinity to 0, and then concave up from 0 to infinity. And of course, you guys can graph this on Desmo so that you guys can visually see it, but I'm not going to do that. Okay, for number 2, we want to write the equation of the tangent line again, where t is equal to 1. So once again, I need to figure out what my rectangular coordinate is. I'm going to plug in 1. So that's 2, 1. Need to figure out what dy dt is. That's 2t. Need to figure out what dx dt is. That is 3. So that gives us dy dx to be 2t over 3. I'm going to plug in 1, so that's going to give me 2/3. And then the equation will be y minus 1 is equal to 2/3 x minus 2. All right, same thing with number 3. So determine the concavity here for the parametric equations. So in order to figure out concavity, I need to get the first derivative, and then once I get my first derivative, I'll use that to get my second derivative. dy dt is equal to 3t squared plus 2t. dx dt is 2t. 3t squared plus 2t all over 2t. Probably simplify this again. So that's going to be 3 over 2t plus 1 as my first derivative, which means that my second derivative, once I do my little formula here, that is going to be 3 over 2 all over 2t, which is going to be 3 over 4t. And then since the only place where I am undefined or I have a 0 is going to be at t is equal to 0, and then make your little sign chart. We're going to be negative from the left of 0 and then positive from the right of 0. So once again, we have concave down from -infinity to 0, and then we're concaving up from 0 to infinity. All right. I'm not going to do number 4, but I am going to do number 5. But I'm only showing the stuff for number 5 just because you could put this into the calculator. So it's asking us what's the length of the arc from t is equal to 0 to t is equal to ln of 2. Remember that the length is going to be from a to b of x prime of t squared plus y prime t squared dt. So this is going to be from 0 to ln of 2. And then we know that the derivative of t squared is 2t. And then the derivative of 2e to the 2t is going to be 4e to the 2t, or dt, oops, dt. And then put that into the calculator. Okay. Number 6, what's the slope of the tangent line where t is equal to 2? Once again, that's just going to be figuring out what dy dt is. This one's a little bit harder. But once you do that, all you have to do is just plug in 2. I'm not asking you guys to simplify this, so you could just straight up plug this in and then call it a day. That's it. This one, though, I am going to do because I am asking you guys to find the second derivative. So finding the second derivative here means dy dt being 4e to the 4t plus e to the t, and then dx dt is going to be equal to 2e to the 2t. So this gives us 4e to the 4t plus e to the t all over 2e to the 2t. Now, you should probably simplify this a little bit together using your properties. So this is going to be 2e to the 2t plus 1/2 e to the negative t, just so that it's a little bit easier for us to work with. Because then we could take the derivative of this. That's going to be 4e to the 2t minus 1/2 e to the negative t. So that's the derivative of the first derivative, over dx dt, which is going to be 2e to the 2t. So this right here is my second derivative. And that's it. And then same thing with number 8. What is the second derivative in terms of t? It does tell you to simplify your answer to one trig function. So dy dt is cosine of t. dx dt is negative sine of t, which means that dy dx is negative sine of t over cosine of t, which is, cosine of t over negative sine of t, which is negative cotangent of t. Simplify that. And then the second derivative is we gotta take the derivative of negative cotangent, and that, it's been a while since I did that, so let me think about that. The derivative of that is negative cosecant square of t. So then we get cosecant square of t over negative sine of t. And then remember how cosecant of t is the same thing as 1 over sine square of t. So then I could rewrite this as 1 over negative 1 over sine cubed of t, which is what we want. I know, very cool. All right, so after this, we're gonna do particle motion with vectors.